Hey guys, it's me, Miss Mills, and welcome to Mrs. Mills' Math Time. The whole point of this video is to help you out with simplifying expressions notes. I know it does say review notes on there, but that's because you haven't seen it this year. You have seen it in previous years. We're just reviewing it this year before we move on to simplifying or moving on to two and one-step equations again, and just making sure that we have our basics down before we move on to new content. So again, yeah, we're going to go over simplifying expressions today. Now these notes are interactive. That means you have to watch this video in order to get answers and explanations for the whole note. So I highly recommend watching the video. And if you are watching it, that means you are hearing me saying that right now. So if you're watching it now, don't turn it off. Just like stick with me through the whole thing, please. Okay. So first things first, we need to figure out, well, for simplifying an expression or expressions, what is an expression? Well, an expression is a mathematical phrase that contains, numbers, variables, and operators, which are like addition and subtraction. And an expression does not have an equal sign, though. That's the main difference. So I have an example here. We have 8x plus 1. We have our numbers, variables, and we have our operator, which is an addition sign. There's no equal sign here, so this would be an example of an expression. So then, next question is, well, then what's a term? So a term is a constant or variable in an expression. Terms are separated by the minus and addition, or sorry, the subtraction and addition sign. So I gave you another example of an expression, and I highlighted in pink what the terms were in that expression. So the terms in this example expression was 6x, 10y, 13, and 5z. Okay, so all of the numbers and variables in between the operators, which are the addition and subtraction signs, are going to be your terms. All right, so what is the coefficient? Well, the coefficient is the number that's in front of your variable. So again, I gave you another expression. This example was 7x plus 10 minus 2x. The coefficients in those terms are 7, because 7 is right next to that variable x. And then another one is negative 2, or sorry, just 2, because 2 is in front of that variable, which is x. 10 is not a coefficient because there is not a variable or a letter directly next to it. So the only coefficients in this particular expression right here is 7 and 2, okay, because they're both next to those variables, which is x. All right, so now that we've gone over that, what are like terms? When I talk about simplifying expressions, what that means is you're going to combine your like terms. So let's talk about what a like term is. So in order for a term to be like a like term, they must both have the same base, which is a fancy word for variable. So they must have the same variable, and that variable must have the same exponent on it. An exponent is a fancy word for a power. So again, I give you another example. This expression in particular is 2x plus 3x squared minus 4y plus 6x squared. I circled the two terms that are like terms. The only two that are like terms here are 3x squared and 6x squared, because 3x squared, they have the same variable, which is x, and that variable has the same exponent, which is 2, okay? So 2y is not a like term because it does not, or sorry, 2x, my bad. 2x is not a like term because it might have that correct variable, but it doesn't have the correct exponent, okay? It has to be x squared in order for it to be a like term with 3x squared and 6x squared. And then 4y, of course, that's not going to be a like term because it doesn't even have the same variable. It's y instead of x. So 3x squared and 6x squared, they have the same variable and exponent, making these the like terms. So in order to simplify these, is what you would do is you would take these like terms and you would combine them. So what we would do is we would have 2x, and then we would take that 3, and we would leave it there, sorry. And then we have that 3x squared, and we are going to add that by 6x squared. So what we would get would be, well, let me do it this way. We have 2x added by 3x squared minus 4y plus 6x squared. All right, so, oh, kick me out. That stinks. It's not gonna let me show up easily. There we go. 5, 7, 8. All right, I'm sorry. That usually stays on for a little bit anyway. All right, so here's your expression. We have 2x plus 3x squared minus 4y plus 6x. Again, we figured out that our like terms are 3x squared and 6x squared, okay? So what we can do here is we're going to drop down this 2x because we can't combine that with anything. We can, though, add 3x squared by 6x squared. So 3 plus 6 is going to give us a positive 9. We bring down this like term, x squared, okay? And then again, 4y, this negative 4y, it's not going to be combined with anything, so we can bring that down as well, giving us our final answer. Whenever you're combining like terms, you have to be careful with your operators, your subtraction and your addition signs, okay? So we'll do more examples together, but you do have to be careful, make sure that you know what you're adding, what you're subtracting, so you can get the correct answer. As you see here, we had a negative 4y. Well, we had to bring that whole thing down, okay? We couldn't just make it plus 4y. We had to bring down the operator with the 4y, okay? But we'll do more examples of that. All right. So those were the like terms again, 3x squared and 6x squared. They both have the same variable and exponent. All right, so what we're going to do on this slide is we are going to be figuring out, are these like terms or are these unlike terms? So what we're going to do is we're going to go over, well, are these like or unlike, and we can take our little circle and put it over the correct word that goes along with it. So for example, if we're looking at number 1, we have negative 15x and negative 15. So these two have the same number, that is correct. But they are not like terms because they do not have the same base or the same exponent. This negative 15 has a base or a variable of x. This negative 15 doesn't have a variable at all. So these are not going to be like terms. You cannot combine them. So what you're going to do is you're going to take this circle and you're going to put it over unlike terms. The next one we have is we have 1/4 c, and then we have negative 9c. Well, these both have a variable or a base of c. Neither of them have an exponent that is bigger than 1. So since these both have the same exact variable, which is c, these would be like terms, and you can combine them. All right, here's our next one. We have 2.5x squared, and then we have 3.5x squared. Again, they have the same variable, which is x. And then they also have the same exponent, which is x squared. Since they have the same variable and exponent, these will be like terms, and you could, in fact, combine them. All right, this time we have 6y and 6x. Well, y and x are not the same variables. They're two completely different letters. Therefore, these are not going to be like terms, and you could not combine them. All right, we have 30 and negative 25. So these are going to be like terms. Neither of them have a variable and neither of them have an exponent. Since they are just regular numbers, you can in fact combine regular numbers. They do have the same variable and exponent, which is nothing. So this will be like terms. You could combine them. All right, here's our next one. We have 17b and then we have 1 over 17b. Well, these both have the same variable or base, which is b, and then they have the same exponent, which would be, you can't really see it, but if you have a variable by itself, that's going to be b to the first power. But I digress. They both have the same variable, which is b. Therefore, these are like terms, and you can, in fact, combine them. All right, so our next one, we have 10m, and then we have 10m squared, okay? They do have the same variable, that is correct, but they do not have the same exponent. This exponent would be to the first power, this one's to the second power. So since they do not have the same exponent, they are going to be unlike terms. You could not combine them. Even though they do have the same variable, but since they don't have the same exponent, you cannot combine them. And the very last one, we have 2.2n, and then just 2.2. or sorry, 2 and 2/10 n, and then 2 and 2/10. Again, these do not have the same variable. The first one has an n. This one doesn't have anything. These are not going to be like terms. You could not combine them. So, hope that helped out. See some of these examples. If you have any questions about that, let me know, and I'll help out in any way that I can. All right, so now let's talk about again how to simplify expressions. I told you we would be doing more examples of this. So to simplify these expressions, you have to combine the like terms. So let's look at number 1 real quick. We have 13r. We're going to add that by 5r, and then we're going to add that by 2n. All right, so here is our expression. So again, the only terms that we can combine are our like terms. There's only 2 here that are like terms that have the same variable and exponent, and that's going to be 13r and 5r. Okay, they both have that same variable, which is r, and then the same exponent because, you know, when you don't have an exponent on it, that would be r to the first power. You just have to automatically assume that that's there. So since these are like terms, we can in fact combine them. So we have 13 plus 5. That is going to give us 18. And then we need to bring that variable down. So we combine that term. 13r plus 5r will give us 18r. And then 2n, we can't combine that with anything, so we can go ahead and just bring that down. So here would be our final answer. We have 18r plus 2n would be the simplified version of this expression. So what we can do is we can go back to our notes and we can write down where it says type in answer here, 18r, and we're going to add that by 2n. All right, so the next one we have is we have 1, this is going to be a lot to write up. We have 1 and 6/10 w. We're going to subtract that by 1 and 2/10 w. We're going to add that by 3 and 5/10, and then we're going to add that by 4 and 7/10 w. Alrighty, so let's go ahead and combine these terms. Alrighty, so again, the only like terms we have here is, well, first you need to identify those. Those are 1 and 6/10 w. We're going to subtract that by 1 and 2/10 w. Both again have the same term, which is w. And then one more has the same term, which is 4 and 7/10 w. So what we can do is we're going to have 1.6 w. We're going to subtract that by 1 and 2/10 w, because when you simplify an expression, you work from left to right, just like how you would read. So our first part is going to be 1.6 w. We're going to subtract that by 1.4 w. Okay. So 1.6 minus 1.2, well, that's going to leave us with 0.4 w. Okay. We can bring down this point, or this 3.5, or 3 and 5/10. And then our other like term that we had is plus 4 and 7/10 w. Okay, so again, we need to see that these are both, again, like terms. We can combine them. So now what we have is 0.4 w plus 4.7 w. So you would add those. 0.4 w plus 4.7 w is going to give us, and I'll bring this down over here, 5.1 w. Okay, we can mark those out. And then again, we can't combine 3 and 5/10 with anything, so here is our final answer. So again, we combined our like terms starting from left to right. We subtracted 1.6 w by 1.2 w, and then we took that answer and we added it by 4.7 w, and then 3 and 5/10 just kind of came along for the ride because it couldn't get combined with anything, so it had to be in our final answer as well. So what we're going to do is we're going to go back to our notes and we're going to write down where it says type an answer here, 5 and 1/10 w. We're going to add that by 3 and 5/10. And then the very last one, and that's going to be hard to write on my iPad, we have 2b. We're going to subtract that by 9. We're going to add that by 8b. We're going to subtract that by 7 minus b plus 14. All right, so again, we need to identify all of our like terms. We have 2b and 8b are like terms. And then negative b is a like term. And then our other like terms is negative 9, negative 7, and plus 14. Okay, so I'm going to combine 2b, and I'm going to add that by 8b first. Okay, so 2b plus 8b is going to give us 10b. So I already took care of those, and then I need to subtract 10b by minus 1b. So 10b minus 1b, well, I'm going to go ahead and erase this. 10b minus 1b is going to give us 9. Oops. Going to give us 9b, so I went ahead and used that. And then I can combine the rest of my like terms. I have negative 9 minus 7, which is going to give us negative 16. Okay, or I guess I can go ahead. I'll write that right here instead. We have negative 16. And then I need to do negative 16, and I'm going to add that by 14. And that's going to leave me with a negative 2. So negative 16 plus 14 will leave me with a negative 2. I've combined all of my like terms. And what I'm left over with is 9b is subtracted by 2. That is the most simplified expression of the above expression. So again, what I can do is I can go down here and I'm going to write 9b, and we subtracted that by 2. And that's all you have to do there. And then the last thing we're going to talk about today is how to simplify using the distributive property. So when you have the distributive property, what you're going to do is you can multiply each term inside the parentheses by the number outside the parentheses. So if we're looking at this one, I'll just write it here real quick. We have a in parentheses a plus c. So what you would do is you would multiply this a by b. So a times b is ab. And then you would multiply a by c. Okay, you multiply what's outside of the parentheses by everything inside the parentheses. So a times c would give us ac. Okay. And then another example, let's say we have a and then a minus, b minus c. Same thing, we're going to multiply the number outside of the parentheses by everything on the inside of the parentheses. So a times b, well, that's going to give me ab. And then a times negative c, you have to be careful, okay? A times negative c is going to give me a negative ac, and that would be my answer. So let's do some examples real quick, and we will be done. And everything I just did is right here. And then I put right here as a reminder, when you're multiplying, be careful with when you're multiplying positives and you're multiplying your negatives. Remember, a negative times a negative gives you a positive times a positive gives you a positive, but a positive times a negative will give you a negative. So do be careful with those rules. So let's do some examples together. Our first one we have is 4 and then 2x plus 3. So again, what we're going to do is we're going to multiply our outside number by everything on the inside of the parentheses. So first thing we're going to multiply is 4 times 2x. Well, 4 times 2x is going to give us 8x. 4 times 2 is 8, and then we have to add that x to it as well. Keep that x there. And then I'm going to multiply 4 times 3. Well, that's going to give me a positive 12, so that will give me my answer of 8x plus 12. So I can go back in here and I'm going to write in 8x plus 12. All right, so same thing here. We have 4. We're going to multiply that by 2x minus 3. Very similar, except we have a different operator here. We have a subtraction sign. It's going to change the answer just a little bit. First, we're going to multiply 4 times 2x. Well, again, that will give us 8x. And then 4 times negative 3 is going to give us, so a positive 4 times a negative 3 is going to give us a negative 12. Okay, so that will be our final answer because we cannot simplify that any further. We do not have like terms. So what we're going to do is we're going to go back and we can type in 8x. We're going to subtract that by 12. All right, so this time we have negative 4. We're going to multiply that by 2x plus 3. Same thing. Negative 4 times 2x, well, negative times positive is going to give me a negative 8x. And then negative 4 times positive 3 is, again, that's going to give us a negative, and that'll give us a negative 12. So that'll be my final answer. We cannot simplify that further. So what we have here is negative 8x minus 12. And then last but certainly not least, what we're going to do today is we're going to have negative 4, and we need to multiply that by 2x minus 3. So again, we're going to multiply negative 2 times 4. Well, negative times positive is going to give us a negative 8x. And then negative 4 times negative 3, well, 2 negatives actually gives us a positive. So negative 4 times negative 3 is going to give us a positive 12. And I have simplified my expression. So what we have left over is negative 8x plus 12. All right, guys, sorry for the lengthy video, but I hope to see y'all soon. If y'all have any questions, let me know, and I will help out in any way that I can. I hope y'all have a wonderful week, and I will see you later. Bye.